So, hi and welcome. I hope you had a good day today. It's the last talk of today, and I'm Victor from the performance team. So, I do tickets for clients when they report a performance issue they face with their database, or also I help part-time with the internal team who manages the deployment of Odoo.com and their own performance issues we face internally with 2,000 employees and a public website. Today I'm going to talk about a generic patterns to avoid when you write code that are technically performance bottlenecks and like easy mistakes to spot and stuff that you shouldn't have the need to open a ticket for it anyway, and it's something that can easily be spot and fixed. So I made a pad UXP24 PV. You can scan and ask question. In the end of the talk, I will try to answer it to the best of my abilities. So on today's agenda is going to be a short bullet points list of typical patterns that are issues or recommended as good coding practices, but sometimes they occur like a performance issue. We are going to talk about what's the function and the property, when to take them and not, what's an invariant, about of the prefetching, batching your CRUD calls, what not to do in a compute store field, the n+1 problem, which is like queries in a loop. It's a popular problem with ORMs, and how to avoid it in Odoo. A short mentioning on indexing. I did a bigger talk at indexing last year, and you can check it on the Odoo.com YouTube channel. It's called Performance PostgreSQL. It goes way deeper in detail for 1 hour about the inside and out of the type of indexes and how to deploy them. I'm just going to mention the good places that seems nice to put one by default. An issue with save points that's like really esoteric and goes deep end into the source code of Postgres and what kind of issue it can raise. And also like the ultimate debate of do I put a list of IDs or do I do a subquery, which is a recurrent issue. And the thing is like it depends when and sometimes you put them or not. So properties. Properties in many programming languages is just a function, but it's technically a function that takes no parameters and has no parentheses. What you say, what's the performance bottleneck about it? The thing is like it betrays expectations. Like you expect something that's fast, that is accessible like a field. The thing is like sometimes it's not. It's a library call, it's a call to a time zone resolution which require a syscall to read a file which is like request the time zone of the server. Jesus6 call is like slow. The thing is like if you have a property, it's going to be called frequently because the developer doesn't know the incurred cost. The idea is like if it acts like a function, it does a lot of stuff. Even if it's like just reading a file, it should be a function, even if it's like a function that takes no parameters. This is a recurrent issue in JavaScript code. So if you have a property, make it really short. That depends only on local variables. It's like just a short local if-else, like just a little compute. Keep them lean and simple. And for something that looks like 5 lines of code, make it a small function. At least the caller would know that it's a function, and we'll try not to call it too frequently, especially like in a long switch case, in a for loop or something that can be batch, for example. Hosting invariants. Invariants is like a fancy term, theoretical term to say for a specific block of code, there's some part of the code that doesn't change and doesn't depend on the outer context. The idea is like if you have an invariant, here in that example I gave is like a computation method, whatever. It takes no parameter and returns just some kind of static result. The idea is like you don't need to call it every time in every loop at every iteration because it doesn't depend on the variable of the loop. It doesn't depend on the context. It doesn't depend on the local execution environment. So you can just host it outside. It seems simple at first, but the thing is like when this computation seems like a small function that calls another function that calls something else, you can quickly grow into complexifying your code for nothing, especially transforming a code that should be linear into like linear, quadratic, or cubic code, which is like a performance detriment in general. There's also the idea, okay, I'm going to spot loops, but there are loops that doesn't look like loops. It's like usually functional idioms of using filter. Filter is like linearly going to iterate over whatever you're trying to iterate of. It's like some kind of iterable, like an array or hash map or something. And usually you pass a lambda to it. A lambda is like a function that's being called for every item. So in the end, if you have a function like your computation function in that lambda, it's going to be called for every item. So it's like a loop, but it's just not visible, and it's not easily spotted quickly because there's no keyword for it. The question of should I paginate or not if I make a new web view, for whatever reason, the answer is always yes. there's no exception of I'm not going to paginate something. The reason is once you have a browser that has finite resources and you cannot display an infinite amount of data. Like it might work with demo data, like with 22,000, maybe 20,000 records, but when you have 100,000, 1,000,000 records, which comes over time with a database that has, for example, 5 years of experience, your view is going to break because either you're not going, the request will time out on the server side, you might face memory issues, the browser may crash front-end side when it tries to render. So the idea is like, if you have a view, consider some form of pagination or at least something that's controllable by the user. We had a few issues like these on the last year's deployment, and it's an issue that can easily be fixed. So the prefetching in Odoo, it's like a bit of a term that's not really precise because there are two mechanisms for prefetching. You have the field prefetcher, which is the select statement basically. So the select statement in your database, it has what's called the selection variable list, and that's the fields that are going to be selected on set table. The prefetcher, the idea is like if you request that I'm reading name on said record, there's a high probability you're going to read another field of that record. So an optimization for the ORM to avoid to do the queries multiple times for each field, it basically selects all the fields on that model that are of course not set as prefetch false. And that usually helps with optimization when it comes to avoiding doing multiple queries because a query has a cost, especially in latency, and also the parsing and deserialization execution on the database. There's also another prefetcher, which is called the row prefetcher, basically. And that's the idea that you have a record set and you're iterating over the record because you want to do something with them. The idea is like, if you're going to read the name of some record of that being part of a record set, there's a high probability you're probably iterating over it and you're going to read the next name on the next record. So an optimization the ORM does, it's going to prefetch, so it's going to select all the IDs that belong to the record set on the first read on the first record and put them in cache. So at the next iteration of the for loop, you're going to be to have a cache hit and not do a query for the names for the for the first to the last iteration of the loop. So what's the issue with the prefetcher? As everything, it's like a mechanism that can be abused. The issues that you may face frequently is that you have really large models. Odoo, by like conception, extends models when you have additional modules. So you add additional columns to your table, which makes the rows actually large. And especially if you have HTML fields, images that are inlined as base64s, what happens is like when you have the prefetcher that's going to read, let's say, all the images of a record set and you have 10,000 of them, that's actually quite a lot of data and everything is put in cache. And you may hit your memory limit of your worker and have an out of memory issue and basically your process is going to be killed. So to avoid that, for example, that's often an issue when you have a record set. And let's say you want to filter it by some kind of type. You're basically, you have a record set given from the function, you want to filter by a type. You're going to probably use the filtered method or filtered domain. The thing is like you're going to iterate over all the records and read the type that you're trying to filter by, but the prefetcher system is active. You're going to prefetch all the other fields, but you don't care. You just want the record set that's being filtered. You don't care about reading the other fields. And usually may face a memory issue. A fix for that is like you can use a context key which is called prefetch fields false, and in that case it disables the prefetcher for the fields for that particular instance of the context you're using it for, and you're going to make every query for yes the reading of the state, but the benefit of it is like you're not putting large values in the cache, so you're potentially not bloating your system. Also an issue with really large models is like the serialization part of it, because of course everything needs to be read from database, it needs to be transferred, it needs to be read, it needs to be sent to the front end. It's additional cost that you may not face it as a one-time go, but if it's like a frequent call, like if it's a hot path, you may start the slowness might start to accumulate and actually feel sluggish. Then what's the benefit of like I can disable the prefetching everywhere and it's going to work nice? Well, you have too many queries, which is like the issue that the ORM in the beginning tried to fix. Too many queries, it might seem nice, but it's actually really slow for the latency point point of view, because you may have a server that's not at the same place as your Python server, and also there's a whole like the problem of like the serialization part of it, because for every request you do, you're going to write to network, read from it. There's like a physical impact of it. You can only transfer as fast as the speed of light, and that has a cost. OM CRUD calls, the CRUD calls are like your create, update, and delete calls. The generic idea is like, because there's a lot of business code in them, it's usually going to be slow calls. The idea is to batch them. They take in place as a parameter a list of var lists, so you can create multiple records at the same time, and that's going to benefit a lot your code, because if you're not batching your CRUD operations, every other call on CRUD operation inside your CRUD operation that you don't know, you're not aware of, they're also going to not be batched because they expect also a batch. So if you batch your CRUD calls, all your code, like you may have an exponential increase in performance just because you created your records at the same time. And that's a frequent issue. The thing is, like, the example I give are like obvious because they stand out. When you look at your code and you have a performance issue, consider maybe, because it might be indirect, you may have a for loop in one module that calls a function in another module that does some kind of write, create, unlink. Also, the unlink is like also invalidating the cache. So if you loop over an unlink, you're invalidating the cache multiple times, which is not necessary. In Odoo 18, there's a big new improvement that comes to the copy. The copy is now finally batched, so you can copy a whole record set at one time, which used to not be the case, because the copy by default, you could get a record set, but it was basically a lie. It was looping over the records in the backend and copying one by one. Now this has been batched, and that's a huge improvement. For example, depending on workflow, you're copying a planning with like multiple shifts, or you have a project template for some kind of large manufacturing, and you have, let's say, 500 tasks in them. Copying them used to be a pain, but now it's like way better, and almost instant. So yeah. Compute stored fields. So they are convenient, and they are usually what a person falls back to when they have a compute field that's slow. They say, I'm going to make it stored, so I'm not going to compute them when I read them. The issue is like it tends to be like a convenient way to put business code that might be necessary to be put in CRUD calls, because like you can just define the dependency, and you know that if that thing changes, you don't need to basically consider all the possible endpoints that your code is going to change. You know that if the dependencies change, your code is going to be called, and it's going to be okay. But the idea is like in a compute store field, at every write, it has a cost on that dependency. If you change the dependency, you're going to have to recompute the compute field. This is an issue for like if you're doing enormous operation like installing a module and you have already populated data, upgrading a module, and also at importing. The idea is like if you have a compute store field, try to keep it lean if possible. And also do not do lib calls and HTTP requests. For example, like a simple example, you have, let's say, a model and you need to check some validity to some external service to validate that whatever value you're trying to change is actually valid, and if not, change the model to an invalid state or something, which is sometimes unnecessary for ADIs and stuff. The idea is like, if you have a module, if you have already 2 million records on that table, and you need to install a module that has some kind of compute stored field that does an HTTP request, at the installation process, because there's no value for that field, we need to compute them. So we're going to compute for 2 million records. And that means you're going to do 2 million HTTP requests to whatever service. If you do them at the same time, there's a high probability you're going to be rate limited, blacklisted, and it's not going to end well. The idea is like if you have those kind of workflow, either offset them as a job, as a cron job, do them as posteriori, like after the upgrade if possible, disable the field. You can also override in the init, you can override when the creation of the column is made to use a raw SQL at the installation of the column. So you can avoid, because they're going to be already a value in database that you put manually with SQL. You can basically, the ORM at installation will skip the compute stored because the value is already present in cache. So it says, oh, I have a value, I don't need to recompute it. The n+1 query problem is the typical problem with ORMs. is that you have usually some kind of work to do on the model, and that model is linked to other models. An example is like you have a car, you have 4 tires, and what do you want to do for the tires, for example? And the idea you may find it's a typical example of a search in a for loop. So the search, in any circumstance, it does a query. Like you're going to do a query to the database. The idea is like instead of looping over your records and trying to search whatever commodore you're using on the foreign key, that okay, for that commodore I want to check to get the tires for that car in particular. I have, let's say, 4 cars and I want to do something with the tires. So for each car I look into tires, I try to find the tires that are linked for the first car, so you're doing a query and then you do something with it. The idea is like you can batch that search with the read group. The idea is like you can use a read group, read all the tires by car, group them by car, then loop over that data and do whatever work you did. That's one query for the whole batch. This is the type of code that really scales really poorly, especially in like large volume of data. If your record set is like 100K records, it's 100K queries. There's no way to avoid it. So this is like a pet peeve of mine, is like the usage of non-start, non-searchable field as a search object. By now it's been raised as an exception, so if you try usually to read a field, to use a non-stored, non-searchable field as a search criteria, is going to throw an exception. But there's one caveat, is use them in related fields. That's usually an issue with studio fields. Although what's the issue about it? It's a huge performance bottleneck, because when the ORM tries to call the search method that doesn't exist, there's a fallback, and that fallback is in an empty domain. If you have a table that's like on a model that's gigantic, I'm talking millions of records, and you're doing like a search, an example is product variant ID with not S. It's a technical field that's just a compute field that's non-stored and no searchable method. But it's used as, I want to have the first variant of my product template. And it's used in Studio as a related field for whatever model I want to extend and add whatever product is linked to whatever record. The issue is like at each resolution of the related, you're going to basically call for all product variant IDs with an empty domain, because we need to search on the field what field on product variant ID matches my template. There's no search method on it, so the ORM is like, okay, I'm going to the fallback, an empty domain, and that's like a sex scan guaranteed on your table. That's millions of records. So don't use them. They are banned for usage. They are just a warning for resolution of related field. Use alternatives. For product variant ID, there's product variant IDs, which is a compute field with a search method, and you can just like use it as regularly. It just returns all the variants of the product. So indexes is like the common 101 of I want to improve my performance of my system. You should add indexes. I had a Modin tab talked last year, but this year I'm going just to mention that there is usually a foreign key. In most cases, if it's on the big database, on the big table itself, it's better to index it than not. Why? Because Odoo, as the way it works, every model is going to read something from another model to link or some condition. And usually it's going to be joined with a foreign key. So if your foreign key is not indexed, and there's no other criteria to optimize the query, usually you're going to fall back on a sex scan. So it's better to add an index, then later on find out that it's not necessary, then remove it, than just not do it at the start. That's usually an issue with studio fields, when people add foreign keys as like a foreign key on the new model, and they completely forget to just add an index on it. It's better to add it, so at least it's not problematic. Yes, an index takes this space, but it's a better trade-off. It depends. Also, weird part to put an index that are not obvious is like when you have a dependency that's transitive. So if you have, for example, a field that depends on, let's say, model foreign key dot name of another model. When the ORM resolve creates the dependency tree, when it needs to establish, do I need to recompute set field or not? It creates a tree, like the inverse tree. And that tree, to basically find which name changed and I need to recompute, it does a search on the model. Okay, on that model, for that foreign key with the ID 1, I need to get the name, but that's a search. And that's a condition on your foreign key. If it's not indexed, it's a sex scan at the ORM level for the dependency resolution. And the thing with dependency resolution is like if you have a lot of interconnected models, you may need to build it the same tree multiple times for different record sets. So it's like, it's a good like hidden way to maybe add an index that can boost your performance like quadratically. I recommend, if you want more in-depth details about the types of indexes, where to use them and not, to watch my last year talk. That's more in depth for 1 year. Sadly, in 30 minutes, I cannot squeeze that information. So an interesting point is like the save points. We all love them. It's easy. They allow us to basically roll back partially in transaction. Let's say you have you're processing some invoices. You want to do something with them, for example, with an external service. So you make a save point. You say, okay, I have a save point. I do my HTTP request. If the government tells me the invoice is not good, I can mark it as an error or roll back the save point. But there's an issue at Postgres level. So Postgres has a cache for the save point in Postgres term is like called the subtransaction ID. And they have a hard-coded cache value of 64. What does it mean? So Postgres needs to do bookkeeping for like keeping on, when you have parallel requests, it needs to keep track of, okay, which process has ongoing save points, like ongoing subtransaction ID, and needs to broadcast them to the other process so they are aware, okay, this record that got updated, there's a lock on it for that subtransaction ID. So there's a lot of bookkeeping done. That bookkeeping is actually fast when it's in cache, and that cache has 64 slots. The thing is like, after that, Postgres relies on the fallback of writing a file to the system, and that file is like guarded with semaphores, locks, and there's a lot of contention. The other issue is that this cache is global for the cluster. So if you have multiple databases, and you have one transaction on one database that basically consumes the cache, all your cluster suffers from it. And it's actually quite a large performance issue. What's the solution? I mean, I'm looping over my records and I'm releasing the save point at each time. The thing is like, that cache is not released until the transaction is either committed or aborted. It's not enough to just release the save point. So okay, I understand that it's an issue to have too many save points. What do I do about it? You can either commit or abort every 50, 64 save points at your own discretion. Now you say, okay, but I don't want to commit my transaction mid-transaction because maybe the data is not in a consistent state. Then the idea is like whatever business case you're covering with your save point, offset it to defer it to a job, a cron job. Just schedule a cron, schedule a trigger for process now. And the thing is like the cron by itself, you can loop over records and commit every time because the commit is not going to it's not going to affect your request that's ongoing. So that's an interesting point to take into advantage. Sadly, as of now, as of PG16, there's no possibility to, you can, at the cluster initialization, specify parameters, but at Odoo, we prefer to rely on the vanilla installation of PostgreSQL as from the repository. In PG17, that's just brand new. They seem to have added a parameter for it, but as of now, it's something to take into account, especially for like large deployments, like for example the SaaS when we face this issue. And the last point is going to be, do I use a list of ID or do I use subqueries? And it's the end, it's a never-ending debacle. As of now, the ORM moved a lot of its code to generate subqueries because it's the good catch-all situation. But there are issues because subqueries are technically optimization barriers. So when Postgres makes a query, it needs to process it, make a plan for it, and a subquery is treated separately. There's some initial pre-processing of estimation. Can I inline the subquery inside the outer query? But if it can't, because of constraint, usually the subquery is planned separately. That means also that the result of the subquery is there's no statistic for it. So Postgres is I have a subquery, what do I do with it? Well, I mean, I will estimate that I return 50% of the rows, and that's a hard-coded value in Postgres. Depending on your context, you may end up doing a query that's completely overestimated, underestimated, that's completely off the chart wrong. And the solution is well, you can inline it in the case, only in the case that the subquery returns a really small list of IDs. A list of IDs, what's the advantage is that it's not a subquery, so it's planned globally in the outer query, and you have the correct statistic because you have Postgres knows that, okay, for that foreign key, I'm looking for the IDs 1, 2, 3, 4. And Postgres has a histogram of statistics, and then knows, okay, for the value 1, I know that I'm going to take 10% of the record. For the value 4, I'm going to take 1%, and for the value 3, 3%. So it can accumulate and know, okay, I'm returning 23% of the records, and usually you have a better plan and a better estimation. The issue with list of IDs is like when you pass a gigantic list of IDs, I'm talking millions, or like it's enough like 10K IDs to be starting to be problematic. The issue is this, like you have too many IDs, and the Postgres statistics basically go are thrown off the chart. And also there's an issue of processing the query itself, because IDs tends to grow large. It's like it's a serial number. So you have the query itself that maybe the text is like 20 megabytes. Then Postgres needs to ingest it, process it, which costs memory. And sometimes you may have your Postgres database that go out of memory just by processing a large list of IDs. So it's, as everything, it depends. In general cases, prefer subquery, but in the case, for example, that you have a subquery that returns only an ID, that's in pseudo context, and that's active test false, maybe you can consider inline it if it doesn't return many IDs. And or maybe just change change the specification of your business code to allow it to have small list of IDs in your query instead of relying on subqueries. That's it. Thank you for the talk. Hope you liked it. Merci. Il y a combien de temps?
Thank you for your talk. At the moment, we do not have any questions, so if you have questions, do not hesitate. And if there are no questions on the pad, do not hesitate to come see Victor after the talk to ask him the questions directly, or to the developer booth on the other side in hall 7. Does anyone have a question?
There's something. Well, if there's no question, no worries. I'll be around. I'll be around also tomorrow if anyone has any question of if you face a performance issue, I will be glad to help. Thank you.
Thank you very much.